So the overall average on the quiz is a little bit lower than last time. But we still had people get 100% on it. And we've had a bunch of people get a little bit better. Some people got a little bit worse. But any comments or questions on that?
Is there a way after class to go over with you on the ones that we got wrong?
Before class is better, but
That's okay.
It will be good to have a review. I think a lot of questions were so tricky.
okay.
Somebody else.
Let me just go over the one that was the most missed. So we had sodium and then C5H7O2 or something like that.
Oh, yeah.
And you had to find the charge of the polyatomic ion, it said, right?
Yeah, what's the charge of the polyatomic?
Well, we don't know that. Do we know the charge of the cation? It's a 1+. How many are there? 1. So that's a positive 1. This side has to be negative 1. How many of those are there? 1. There's no parentheses. Means there's one of them. Do you remember that? Okay. So that means the charge of this polyatomic ion is 1-.
Well, it makes sense when
There were some things that weren't on the study guide either, or the practice exam.
Yeah, what did you get?
Truthfully, like, I studied for like ever, and then when I sat down, I was like, what in the hell is this even asking me? Because I was like, it's not written anyway, like it was
That's still better than mine.
shown or like what was
Okay.
the study
Which
guide.
one? It's better than the last time.
There's one of them.
But to finish up this, the charge you're saying then is a -1?
Uh-huh. That's it.
Okay, because I Googled this afterwards and Google said it was 0.
So the test
So
question,
I'm way confused.
the test
No,
question
Google's
asks for
confused.
the-
Okay, I was trying to get myself straight. It's like,
I can answer your question about that. So
Okay.
the test question asked for the electronegativity of the polyatomic.
right,
So that's what you're saying. Okay, so I was gonna say that's why it's
Yeah.
-1. But when you Google like the whole thing, I did that too.
Yeah, the whole
And
thing
it's
has a
a
charge
zero.
of 0.
That would be because they cancel like each other.
because they cancel each other out.
The whole, because it's an ionic
So the
compound.
whole is-
Yeah.
All ionic compounds are neutral.
Okay, I like studied all the ones you gave us. I memorized all of them. Like, this is not one of them. So I
Yeah.
way overthought it and broke it way down.
Yeah, it wasn't one of them. So it's kind of like doing this, and here's another one that was missed a lot.
I've never gotten a test like that. FYI, that's crazy.
Now, so what are you thinking? We should just do all of our tests in the testing center?
What do you say?
I mean, I took my first one in there and did great, okay?
I mean,
but this one
no,
was just rough.
No,
I was proud of myself. I got this one right. I was proud of myself.
good. So titanium, Roman numeral 4. Whoa. Yeah, sometimes. Titanium, Roman numeral 4 oxide. And you had to come up with the chemical formula. So you look up titanium on the periodic table. Symbol is Ti. What does this Roman numeral 4 represent? The charge. 4+. What's oxide's formula? O2-. Main group element, you change the ending to IDE. Then you take the charges and you cross the numbers down. Ti2O4. Do we leave it like that? No, that's a 2-to-4 ratio. We can simplify that to 1-to-2. So it becomes
Oh,
TiO2. Okay? But if we have FeO, for example, and we got to write the name, we do exactly what we did right here. We just did it on the other side because this is the side that we knew, right? On this one, we know this is 2 minus. There's only 1. So it makes it 2 plus. Iron, Roman numeral 2, because that's the charge. Change the ending to IDE. Yay? Nay? What else? Yeah. Well,
it had all the it was a diagram. It had a section, and it asked if it was like trigonal or trigonal planar. I think do you know what I'm talking about? Or?
I'm not sure exactly which one. Did it draw the structure for you?
Yeah, it was like there was like
Oh, okay.
Where you had
So that,
two
it's
things.
like this. Yeah,
yeah.
like carbon, maybe a chlorine and a fluorine or something, then a carbon and a something like that.
Uh-huh, yeah.
And it says, okay, what is the geometry around carbon atom number 3, right? Okay. So here's the central atom. We have 1, 2, 3 regions and 0 lone pairs.
Yeah.
That means it's trigonal planar. Does that make sense?
Yes.
It was like put in the corner though. It
Yeah,
was
there was-
so weird. I don't know.
There was one like.
And it didn't say central carbon 3, it just said 3.
Oh, yeah.
I don't know. It just looked funny. It all looked funny.
All right. Sometimes chemistry looks funny. Sometimes it looks like Chinese. I mean,
It wasn't funny.
I'm not saying Chinese is funny, but sometimes you can't make sense of it, right? Well, unless you're Chinese, right? We good?
Well, we're made out of chemicals.
Yeah. And yeah, if you opened up your body, say, whoa, what's going on in there, right? Okay. Anything else? All right, you ready to move on? Chapter 5?
There's one last question in the exam. Do you guys remember the answer? The last question? Yeah, it's brittle
Oh,
and
the
it's non-conductive, crystalline.
Oh, yeah, that one was,
Actively high.
That was tricky.
What is that?
okay. And I think we talked about
You
this
said
one.
you were gonna get us on that, yeah.
I tried to warn you. Okay, so let's do that one. I don't remember exactly what it says, but something like it's brittle,
Non-conductive.
non-conductive,
Very high
Relatively
melting.
high.
high melting point,
Yep.
okay, there's a lot of things with very high melting points, right? There's metallic solids, covalent network solids, and ionic solids. All have high melting points.
So that's
What about non-conductivity?
non,
Maybe just, so that takes out the metal, right? So that means it's either ionic or covalent solid. Then you have brittle. Are diamonds brittle? No, that takes that one out. And it's just ionic solid. So you have all of them. I mean, you have to break it down one step at a
But if we
time.
put ionic solid into water, it becomes conductive.
Yes. But it just says an ionic solid. If you put it in water, it's no longer solid. Do you get that? So yeah, you gotta read the words and break it down. So one other one says, so for example, I don't know if it was, I don't think it was this exact one. How many lone electrons are around the central atom in this compound? 2. If it said how many lone pairs, it would be 1. So that one, the answers were kind of all over the board, so I'm not sure what happened. But yeah, so you just draw the structure. Notice that there's 2 lone electrons. But that one was, a lot of us. Now, when I say a lot of us missed them, still the majority, the correct answer was answered more than any other answer on all of these. But, okay, maybe that still doesn't make you feel good. Okay.
I'm suing for pain and suffering.
Okay.
For the final test, it's gonna be like.
Is it still 20 questions for the final?
No, it's 70 to 80.
What?
I said
It's still
70
multiple
to
choice.
80.
Because it's for, for 10. And it's gonna
Yeah,
be
it's
kind of-
everything.
And it's gonna be kind of the same question.
But that means each one of them is not worth 5% of your grade,
For us, 'cause then, then you miss more.
right? You miss
Totally
one
vomit.
on the ones with 20. It's like, oh, there goes 5% of my grade.
More questions is better. Including the final though, like any one of them gets dropped?
Yes.
Lowest score.
Yep. So, yeah. So if you like your grade before the final, we can just drop your final and you don't have to take it.
You might as well take it though, right?
Yeah. Well, it all depends on your grade. If you're going into the final, you have a solid A and you get this stuff. It's like, yeah, why take it, right? But you can. You definitely can. Good? So, let's make this one the one that we drop. Oh, then we have to take the final. I mean, I don't know. But you still have your practice test, right? That's 20% of your grade. Your homework, that's 15% of your grade. If you ace that stuff and do all the extra credit, that's going to help. Okay?
And when we have another extra,
Yeah, there's 2 more extra credits.
2 more,
Okay? So, yeah,
when we will take that?
we'll do one this unit in chapter 7. This unit covers chapter 5, 6, and 7. All right, ready to go on to chapter 5 so we can get out of here? Oh, wait, we don't want to get out of here. This is so wonderful, amazing. Okay, here we go.
Make us happy today.
Woohoo! All right, we're gonna do balancing equations. Now that doesn't sound good, but it really isn't that difficult. Okay, and I'm gonna show you some tips and tricks on how to do this. So this is chapter 5, balancing, and this is the stuff that we're gonna go over today. I'm gonna start writing it up there. Would that help? So on this board here, that's kind of what we're gonna cover today. Balancing equations. Now, here's in fact, I'm going to start with an equation that we did the first unit. And we had sodium as a solid. We put it into water, H2O, as a liquid. You remember doing this reaction outside? And we get sodium hydroxide, which is a water solution we call aqueous solution. And we end up with hydrogen gas, and that's what makes it explode. Okay. So I'm showing this just to show you what all of these. This means a solid. This means a liquid. This means a solution of water. So this is dissolved in water. And this is a gas. We good? Okay, now in this reaction, the substances on the left are called the reactants. Any ideas why? Because they react together. And what do? They produce what we call the products. Does that make sense in your mind? So this is a chemical equation. You have the reactants on the left side, products on the right side, and this arrow means yields, makes, produces, etc. We good? Any questions how to read an equation? A chemical equation? All right. So next, let's look at a different chemical equation here. So we have propane, C3H8, burns in the presence of oxygen. And notice, I said oxygen, but I wrote O2, because that's one of those diatomic molecules. And it produces, any ideas what happens when you burn propane? What do we get?
Carbon dioxide.
Carbon dioxide.
And water.
And water. That's it. What if we burn gasoline? Carbon dioxide and water. What if we burn wood, which is another carbon-hydrogen compound? Carbon dioxide and water. We'll get there. This is called a combustion reaction, but we'll get there. Anything look off about this equation?
The H is missing,
Where?
H8 and H2.
Ooh, there's 8 over here and 2 over here. That doesn't look right, yeah? So that's why we have to balance it. Now, an equation by itself without balance, an unbalanced equation, that's like the ingredient list. You guys ever try to make, what's your favorite cookie? Anybody like Oreo cookies? Maybe not your favorite, but okay, is it you ever try making Oreo cookies? Well, all you have to do is look at the ingredient list, is that right? No, right? I mean, you have to be a magic chef to do that, right? So, but yeah, you can't just look at the ingredient list and say, I'm going to make this. Has anybody ever tried doing that with something? No? Oh, oh, you guys need to get out more. No, I'm just kidding. I'm just teasing. No, but every time you do, you just throw your ingredients away, right? It's like, oh, that was nonsense. Well, that's what happened to me anyway. Okay. But if we balance it, it becomes a recipe. And we have to have it balanced. Otherwise, no cooking, right? Well, that's what chemistry is cooking. Whether it's food or, we won't talk about, never mind. Okay. We'll quit about, we won't talk about Breaking Bad. All right. So, when we balance the equation, we use coefficients. You guys know what a coefficient is? So 3x, when we write 3x in mathematics, what's the coefficient of x? 3. Oh, it's a multiplier. we never change the subscripts. Why not?
It changes what it is.
It changes the substance. It's no longer propane and oxygen, or carbon dioxide and water. Okay? Does that make sense to everybody? Okay. Now, before we get into balancing the equations, I want to give you a few tips and tricks. Now, I'm just going to give you a heads up on this. If you don't use these tips and tricks, if you don't remember these, you should still be able to balance them. If you know how to count. In fact, let's practice. Well, when I say count, okay, count. If you know how to count atoms in a compound. How many carbons do we have on the left side? 3. Y'all see that there's 3? How many do we have on the right side? 1. How many hydrogens do we have on the left side? 8. How many hydrogens do we have on the right side? 2. How many oxygens do we have on the left?
2.
How many oxygens do we have on the right? 3. Are we good? Looks like the majority of us can count. Okay, I'm just kidding. Can count number of atoms. So that's what we do. Now, if we put a coefficient right here, what does that mean we do? It means we have 2 carbon dioxides, not just 2 carbons. So that means we have 2 carbon dioxides. So that's a total of 2 carbons and how many oxygens? 4. We just multiply those. Are we good? Okay. So that's kind of how we go through this. Now let me give you some tips and tricks here. And again, if you don't remember these, it's not the end of the world. You still should be able to do this. Mostly the purpose of these tips and tricks are to make it easier, to give you, where do I start? Okay, what do I do next? Okay, the first one is start with the largest subscripts. Start with the compound with the largest subscripts. And it doesn't matter what element you start in that compound, but just start there. Okay? If an element exists multiple times on one side, on either side, then save it for last. So if an element exists multiple times on one side, then save that element for last, meaning count it last. And the reason is because if it's all over the place, we change it over here, then it's going to change it over there, and we're just going back and forth, like, kind of in a nonsense spot. So just save that for last. Then also, if an element is alone, if element exists alone, then save it for last also. Why is that? Because we have everything balanced, and then if we have to change something, we could just change that one, and it doesn't change everything. And we don't have to start over. And we'll go through examples, but does it make sense so far-ish? Okay.
When you mean element, you mean just like one of something instead of
Yeah, so like carbon, So in this one right here, oxygen is alone, save it for last. Oxygen appears multiple times on this side, save it for last. I'm gonna start with this compound because that has the biggest subscripts. Does that make sense? Okay. Next, if you can balance the equation using fractions, then do. But you can't leave it there. So how do you get rid of the fraction in math? You multiply everything by the denominator. If you multiply everything by the denominator, it's still going to be balanced. Good? And we'll go through examples there. If odd amount of one atom or one element on one side and even on the other side, then we use least common multiple. You guys all remember what that is, right? Least common multiple, the lowest number that two things can go into evenly. So what's the least common multiple of 2 and 3? 6. They can both go into 6 evenly. Okay? And is it always you just multiply them together? For small numbers usually. But, okay. Because you can't change a 2 into a 3 or a 3 into a 2. So you just change both of them bigger. And the last one, if polyatomics, exists, same polyatomic, I should say, exists on each side of the equation, then we can treat it as a single component. Now that's a mouthful. We'll get there. You ready for some examples?
Yes, sir.
All right. Let's start with a simple one. Or does anybody want to take a picture of those? We good? Okay. So example 1, we have hydrogen gas with oxygen gas, and we make water. All right. Now, when I do these, I don't show my work. And maybe at first it might be easier to show your work. Get to where you don't have to. Just count one at a time and just make sure it's balanced as you go. But let me show you how to show your work. And then, but at the same time, I'll show you, okay, how do we do this without drawing, without writing all the work? Because it kind of takes a lot of space. But you can. Okay? So hydrogen and oxygen on both sides. And this is kind of what I'm thinking in my mind. Okay? So where's a good place to start? They all have 2, so it doesn't matter. Right? So let's just start with hydrogen. How many do we have on the left? 2. How many do we have on the right?
2.
Okay, good. So you don't have to write those, you just notice there's 2 on both sides, right? Okay. Now how many oxygens do we have on the left? How many do we have on the right?
1.
Ah, it's not balanced, so what do? We write a 2 right there. And that makes so that we have 2 and 2, but what does it do? It changes the hydrogen. How many hydrogens do we have on this side? 4. So we better put a 2 over here to give us 4. And now it's balanced. Do you get that?
Yep.
But do you see how you can do that without showing all of this? Okay, and if you want to show all that, do it. I'm not telling you not to show your work, but, I mean, your call. Really is your call. All right, you ready for a little harder one?
Yeah.
So let's do propane with oxygen gives us carbon dioxide and water. You want to show? Should I show your work? Should I show my work? Okay. Carbon, hydrogen, oxygen. So where should I start? What compound should I start with?
With the lung.
Right there. It's big numbers, right? So I'm going to just start with carbon. I could start with hydrogen, no big deal. Why am I starting with carbon? Because it's on the left and that's how we read. That's really the only reason, okay? It doesn't matter. So we have 3 carbons on the left. What number should go there to have 3 on the right? 3. We good?
Yeah.
Okay. Now we do hydrogens. And notice, I'm going to save oxygen for last because it's everywhere and all alone. Good? So we have 8 hydrogens on the left. What number goes there to make 8? 4. Okay, I see that at least one of us get this. Do we get this? Okay. So we have 8 on the right. And now, let me count my oxygens. Which side should I count first, the left or the right?
The left. That has more. No? I don't know. I don't know.
The one that has more, yeah. The right. Good?
I mean right. The one that.
Yeah. So how many do we have right here? How many oxygens? 6. How many do we have here? 4. That's a total of 10. And what number goes there so that we have 10 on the left? A 5. Do you get that? Not too bad? All right. And do you see how you can do this without writing all this? You kind of just keep track in your head, one at a time. And if you forget what you had, just count it again. No big deal. But if you like to show your work, please do. Okay? All right. Next one. So far we used start with the biggest subscripts. If an element exists multiple times, save it for last. If an element exists alone, save it for last. We did that, right?
Yeah. Teacher, can we do one that has parentheses?
We'll do several.
Oh.
Yep.
I think.
Yes, we'll get there. We're just doing one step at a time. All right, so now let's do another example. And we have iron 3 chloride goes to, breaks down, or decomposes into iron and chlorine. What's the chemical formula for chlorine?
CL2.
Cl2, because it's one of those diatomic molecules, right? That's what we need to know. Y'all want me to show my work again?
I mean, just whatever you want.
Okay. We have iron and chlorine atoms to worry about, and that's it. Well, that's nice. Where should we start?
With the
Chlorine, right? We have 3 on one side, 2 on the other. Even on one side, odd on the other side. What should we do?
we want one.
Least common multiple. You can't make this have 3, and you can't make this have 2. Right? So you just make this side have 6 and this side have 6. What numbers do we put in front of this one to make it 6? And what number do we put in front of this one to make it 6? Y'all get that? Okay? And then we count, since we balance this side, we count this side. We have 2 irons, so we better put a 2 right here so that we have 2 irons. Not too bad?
So always pairs. It has to be.
What do you,
So we cannot be. I'm sorry. I don't know how to say it in English, but it cannot be 3 or 1 or 5. It has to be. How do you say that? How does So it has to be 2, 4, 6.
no?
No. So why we cannot have?
Okay, because we have 2 there. What do I multiply by 2 to get 3? 1.5. I could, I guess, but then I'd have to change it anyway. Can't keep it 1.5. You with me?
Okay. Yeah.
But it's easier if you see that they're odd and even. Least common multiple. That's the easiest way to do it. Okay? Let's do one. So that one was this one right here. We just finished that one. And now let's do this one right. No, not that one. It was this one right here. So now let's look at balance using fractions. So if we have C4H10 plus O2, anybody knows what we're going to get? What's the products?
Carbon
Carbon
dioxide.
dioxide and water. We start with a carbon-hydrogen compound. We burn it in the presence of oxygen. That's what we're going to get every time. Okay, so we have carbon, hydrogen, and oxygen on both sides. And we should start with what compound?
Carbon.
That one right there, yeah? So do you want to start with hydrogen this time just to show you it doesn't matter? Sure. We have 10 hydrogens on the left. So what number goes there to make 10 on the right? 5. So now we have 10. Good. Now let's do carbon. We have 4 on the left. What goes there to make us have 4? A 4. Are you with me? And then last thing, do oxygen. Because it's all everywhere. We have how many for the carbon dioxides total? 8. How many for the waters? 5. That's a total of 13. You with me? So we need 13 over here. What times 2 is 13? 13 halves. Now, You could just do 6.5, right? You could, because that's what 13 halves is. But if you just leave it as a fraction, how do we get rid of that? Because right now, 13 halves times 2 is 13. It is balanced, as written. But we can't leave it that way. You can't have a half a molecule, can you? Okay? So, how do we get rid of this fraction?
Divide.
Multiply
sorry.
everything by the denominator, right? So we're going to multiply this entire equation by 2. Now, I'm not going to write it that way. I'm just going to say, what's the coefficient of that one? That's 1. Multiply it by 2, and I get 2. 13 halves, multiply it by 2, and I get 13. You with me? 4, multiply it by 2, and I get 8. 5, and multiply it by 2, I get 10. Since I multiplied everything by the same value, it's still balanced. It's no longer these numbers. Guess what numbers they are? Oh, multiply by 2 and it's it, right? You don't have to recount if you multiplied everything by the same number. You can if you want. You with me? All right. Ready for the last one? Before you guys get to practice some?
No, I have another question.
Yeah.
So every time we get an impaired, like no pair, I don't know what's that visual. So we divide it, like we do the fraction.
So, do you understand why I did fractions?
It's like 0.5, right? Because it's not a complete number, a pair number.
Okay, and it could be 0.5, it could be 0.3 repeating, it could be whatever. But I counted over here and got 13. What times 2 is 13? No whole number. So we could just do 13 divided by 2, or just leave it as 13 over 2. Do you get that?
What if, for example, what if it's 7?
Okay, so what if we have 7 over here,
Uh-huh,
and we want 7 over here?
uh-huh.
Yeah, let's do that. So guys, this isn't right, but I'm just saying,
Yeah.
what if we have 7?
Mhm.
So then we do 7 halves.
7.
Oh, but what if that was a 3?
Again.
7/3. What's 7/3 times 3? 7. You get that? Yeah. And so this time you'd have to multiply everything by what? 3. Do you get that? Thanks for asking. Okay, any other question before we do the last one? Last tip? All right, so if we have, so this is example 5. If we have NH4 2, parenthesis 2, S, what's that called?
Ammonium.
Ammonium, what? This is just a main group element. Change the ending to IDE, ammonium sulfide. Magnesium nitrate. And we get MgS and NH4 NO3. Good? Okay. Now, guys, you don't have to use this last trick, but I'm going to show you how to use it in case you want to. So we see ammonium on both sides. So I can just say, okay, I have ammonium on both sides. I'm going to count how many ammoniums I have. And then I have a sulfur and a magnesium. And I have nitrate on both sides. And so I'm going to have this on both sides. Y'all with me? Questions? All right. So let's just count ammoniums first. There's 2 of them. How many on this side? 1. So I better put a 2 right there. And, well, since I changed this one to 2, let's just count the nitrates next. Is that okay? We have 2 ammoniums, and now we also have 2 nitrates. Oh, we have 2 on this side as well. Cool. And then, well, since I'm here, I'm just going to, okay, count the magnesiums. 1 on this side, 1 on that side. Great. 1 sulfur, 1 sulfur. Hallelujah. Now, could we just count all the nitrogens, hydrogens, sulfurs, magnesiums, and oxygens separately? You can. Do you want to try it? Just to see what it looks like? Maybe it's not any. Should we try it? Just to see? Sometimes it makes it so much easier, and sometimes it's like, no big deal. Okay? So if it's not working out, then do it the other way. So we have NH4 2S plus MgNO3 2 breaks down into MgS plus NH4NO3. We got NHS, Mg, and O. It's only really one other thing we have to count. Not too different. All right. So what should we count first? What? N, H? Okay, let's count H's. How many H's do we have on this left side? 8 of them. You with me? How many do we have on this side? 4, so I better put a 2 there. Okay. Since I put a 2 here, let's just count these now. Nitrogens. How many nitrogens do we have on the right side?
3. No.
We have 2 in one of these compounds, and we're multiplying it by 2. So we have 4. You with me? 4 nitrogens. How many over here? We have 2 here and 2 there. Good? So 4. And now we got to do sulfur next, maybe. We have 1 on each side. Magnesium, we have 1 on each side. Oxygen, we have 6 on this side. And how many over here? 6. Still not too bad, right? But maybe a little bit more. You can see maybe the benefit of using counting one single term there. All right, ladies and gentlemen, why don't you practice on your worksheet? Because you're not going to get good at this unless you practice. Yeah.
You don't have to count so much. It's interesting, I thought the practice exam was trickier. Cause like there was that one that kind of asked about angles, it was like L shaped. Instead of 90 degrees, like in the rest.
I did it after I took the test, so I just looked at all the answers in the video.
Uh,
Cause I had heard it was a very small field, so I was like, I'm not gonna mess up whatever study I didn't get all.
You did right. You did the right thing.
I think the help for me was, there was the, there was something I had to look
Yeah,
at,
yeah,
but the molecular forces. I realized that if there was a harder question than the one in the practice exam, I wouldn't have gotten it. So I asked ChatGPT to make 6 more that were harder. Yeah, that's the only reason why I got that one right on the actual exam. Yeah, the final one, the brittle, what's called the ionic compounds, yeah.
That was a good thing.
The part that I appreciated was, there was one that if you got sulfur dioxide correct in one of the early questions,
It like
it
answered.
answered 2 other questions.
I got one wrong cause I didn't read it right, which is what I did the last test too.
On my study notes,
I wanted someone new.
my notes for the second exam were make sure you read this time.
Okay, here are the answers. Any questions?
Okay, I know how to count.
Can you go over the first?
The very first one?
Yeah.
Yeah. Okay, moving this up. So we got aluminum, sulfuric acid. Gives us Al2SO4, 3 plus H2. Is that right? Yeah. Okay. So we got aluminum hydrogen and sulfate appears on both sides. Good? So where are we going to start? This compound has the biggest subscripts, right? Should we start somewhere else to see what happens? Or should we just do it that way? No preference? Okay, so we have 3 sulfates on this side. So what number goes in front of this compound? A 3. We good? So that makes it so that we have how many hydrogens over here? 6. So we better have 3 right there to make us have a 6. 2 aluminums. So we better put a 2 in front of that. Just go back and forth till you got it. Did that help? Or do you have a question?
Can you do the
NaNO3? Which one was it?
1, 2, 3, 4, 5, 6. 6 in the seconds.
Okay. Yeah. Let's do it. NaNO3 plus, or breaks down to NaNO2 and oxygen. Do we have the same polyatomic on each side? No, we don't. So we can't use that. We have sodium, nitrogen, and oxygen. Okay. So let's start with what? Sodium and nitrogen are already balanced. Looks like we have to start with oxygen, right? Okay. So we have 3 on this side and 4 on this side. Well, we can't do least common multiple because there's like 2 different numbers here. But here's what we do. This side is always going to be even. Or the oxygen right here is always going to be even because it's times 2. This one's always going to be even. Even plus even is always even, right? We're always going to have an even number on this side. So let's make this even by multiplying it by 2. Do you get that? So we have 6 oxygens over here. But maybe before we do that, before we count oxygens, because they're messy, they're everywhere, let me just put a 2 right there. And I would have to put a 2 right here too, right? Okay. So now let's count them. We got 2 sodiums, 2 sodiums. 2 nitrogens, 2 nitrogens. 6 oxygens, we got 4 here and 2 there. Wasn't too bad if we do it that way, was it?
How
So-
were you gonna do it without putting the 2 in the front?
What's that?
How were you gonna do it without putting that 2 in the front of NaNO2 on the right side?
Uh-huh.
Were you not gonna do that?
I wasn't at first. I was just looking at the oxygens and saying, okay, this is always going to be even amount of oxygens, even amount of oxygens. This side's always odd. Let's make it even. Because odd can't ever be even. So we got to make a balance, right? So that's what I was looking at there. And I changed that to be even. And then I started counting the sodiums and the nitrogens. Because oxygen's everywhere. That's still messy. Good? And that forced me to put a 2 right there. Good? Yeah.
Can we do the second one in the first column?
Yes. So we have C2H6O plus oxygen gas. Anybody know? Oh, we know what we get. Same thing, right? Carbon dioxide and water. All right. So we have carbon, hydrogen, and oxygen. Let's start with that big one, right? Let's just start with carbon. We have 2 on the left, so we better put a 2 right there so that we have 2 on the right. Y'all with me? Then we have 6 hydrogens on the left. So what number goes in front of here? 3 to give us 6. Now let's count the oxygens on the right side. How many do we have here? 2 times 2, that's 4.
7, 4.
Plus 3, that's 7. Oh, here's your favorite number. Okay, so we have 7, and we have to have 7 on this side, but there's 2 places where oxygens are. Do we want to put a number right here, guys? No, because then we have to change everything. So let's not. We have 1 right here, plus what number gives us 7? 1 plus what number gives us 7? 6. So this has to be 6 right here. What number has to go there to give us 6?
3.
Oh. Do you get that? So there's a few other tricks that we kind of can pull out of there, but it doesn't always happen. Kind of fun, right? No?
Way better than the last.
Okay, good. Anything else before we move on? And we can go all night on these, but then... Ready to move on? Okay, we're moving on, but that doesn't mean we should stop practicing these. The answers are on Canvas, so practice. All right, next thing we're going to do is the types of chemical reactions. All right, there's 3 classes of let's see, what should I call these, classes or types? I don't know. There's 3 types of chemical reactions, but there's 5. This might make it confusing. Let's just start. So the first type of chemical reaction is called oxidation reduction reactions. And oxidation reduction, sometimes called redox reactions, these are when electrons are transferred. So when electrons are transferred in a chemical reaction. All right. So let me first talk about why we call them oxidation and reduction. So let's take a metal that we've had since the beginning of time, iron, right? And what happens when we put iron in the presence of oxygen? It rusts and becomes iron 3 oxide. You with me? So iron, we say, does what? Oxidizes. It's oxidized. Good? Iron is oxidized. And so oxygen has to do what? It reduces. It's reduced. Okay. What does that mean? Well, let's think about what the charge of iron is by itself. It's neutral, right? The charge of oxygen all by itself is also neutral. What's the charge of iron 3 oxide? What's the charge of iron in iron 3 oxide? 3 plus. And what's the charge of oxygen in iron 3 oxide? 2 minus. Are you with me? So we did this last unit, right? And if we don't know, we can figure it out. Is that right? Okay. So what happens to oxygen? It goes from 0 to a -2. Its charge is reduced. Isn't that cool? Hence we call it reduction. You with me? Its charge is reduced, and oxidized is just the other one. But originally, this is why we call it an oxidation-reduction reaction. Does it have to have oxygen in to be oxidation reduction? No. So here's a little acronym you can use to remember this. Oil rig. Oxidation is a loss of electrons. And R is reduction, is a gain of electrons. So I didn't have room right there.
So it should be ionic compounds to make this happen.
No. Originally, yes. But, yeah, you can have other compounds too, and we'll go through it.
Wait, what's the G say?
A gain in electrons.
So oxidation.
So hold on a sec. Reduction is gain?
Yeah.
That doesn't make any sense, does it? But if it gains electrons, what happens to its charge? It goes down. You with me? So it's a reduction in charge. That's really, I don't use this, guys. I really don't. It confuses me. But you do have to know what happens to the electrons. That's an easy way to know what happens to the electrons. But if we already know this from the last unit, we know if the charge goes down, it's because we gained more electrons, right? Then we don't have to worry about acronyms, oil rigs that have nothing to do with chemistry. Do you want to know another one that they use? Leo the lion says grr. I didn't like that one ever, but that's because I don't like to memorize stuff. I really don't. But if you can think your way through it, hook it to something. You have to have it hooked to something. Otherwise, you're going to forget it. But, okay. So this right here is one class of reaction called synthesis. What? Oh, that was weird. What does it mean to synthesize? To make something. We take our two elements and we make something with those two elements. Or we combine them. Sometimes it's called a combination reaction. Good? So if we have this type of reaction, it is always an oxidation reduction reaction. Okay? The second type of oxidation reaction, the opposite of synthesis, a decomposition. What does it mean to decompose? To break down, right? So we can get H2O breaks down into hydrogen and oxygen. I'm not going to show you where the electrons are going here yet, because it's a little bit more complicated, because it's not an ionic compound. But for now, if it's a decomposition reaction, it's also an oxidation reduction reaction. And then the next one is a combustion reaction. We already know what these ones are, but I'll remind you. Combustion reaction is like when we have a carbon-hydrogen compound in the presence of oxygen, and we get what? Carbon dioxide and water. We always get the same product, guys. So anytime we have a combustion reaction, it's always an oxidation reduction reaction. We got one more type. Is a single replacement reaction. And I'll show you why we call it a single replacement. So for example, we have aluminum with HCl. And what happens is the aluminum replaces the hydrogen. The aluminum becomes the new cation, kicks off hydrogen, and it becomes AlCl3. How did I know it's AlCl3? Because aluminum is 3+ and chlorine is 1-. We know how to do this. We cross charges and you simplify, right? We still gonna need to be able to do this? A little bit, yeah. Plus, hydrogen is all by itself. So what's the formula for hydrogen? H2, because it's one of those diatomic molecules. Are we good? Okay. So anytime we have a single replacement reaction, it's also an oxidation reduction reaction. But don't be afraid, like, oh, that's so much to remember. I'm going to show you an easy way to do it. But it's good to know this. Any questions with oxidation reduction reactions? So what happens? So do you want me to show you this one? We can show you the transfer of electrons. What's the charge of aluminum by itself? 0. By itself is 0. And what's the charge of hydrogen when it's bonded to chlorine? +1, right? Because it's in group 1 and chlorine is -1. You with me? What's the charge of aluminum when it's bonded to chlorine? +3. And chlorine's still -1, isn't it?
Yeah.
And you with me?
Yeah.
And hydrogen's charge all by itself is 0. So which one is reduced, guys? Aluminum is not reduced because it goes up. Which one is reduced in charge? Hydrogen goes from +1 to 0. That's lowered. You with me? So that's reduction.
That part I don't understand, actually. Sorry.
So reduction in charge. We go from +1 if you have +$1, and you go to $0, you just lost money, right? So we just lost charge. Even though it doesn't go to negative, it's still a loss of charge. And how do we lose charge? We gain electrons, right?
Yeah.
We gained 1 electron, and that's how it got to be 0. You with me? Okay. And then which one is oxidized? Aluminum, because it also changes. It's the other one. Oxidized. Whoa.
So those are the two things we're looking at for.
But
Which one's being oxidized, which one's being reduced.
and guys, we will get into this a little bit deeper next time. I just showed you on these 2 simple ones, but on these ones, it's not as simple. I'll show you that next time. Okay? Any questions on oxidation reduction reaction? Transfer of electrons. Okay? The next type, well, so we have 5 classes of reactions. We have synthesis, decomposition, combustion, and single replacement. We have one more. And this class of reaction tells us the other 2 types of reactions. Is that confusing? You have classes and types? I don't care what you call them, but so we got double replacement reaction is the next type. Next class. Double replacement reaction. And just to give you a general equation here, we have AB, some compound AB, plus some compound CD. And kind of like in single replacement, there was only one atom that's being replaced. Well, in double replacement, guess how many atoms are being replaced? 2, double, right? And so what happens is these okay. So if it is not a double replacement reaction, then it is an oxidation reduction, or we can just say a redox reaction. Is N redox? That doesn't make any sense. Good? All right. So the second type of reaction, and these are double replacement reactions, are precipitation reactions. You guys ever heard of precipitation? On the Weather Channel, right? Well, there's maybe not a Weather Channel anymore, but okay. The meteorologist, okay, yeah.
I'm confused when you're talking about types and classes. What, can you tell me real quick, go back to the
Uh-huh.
one, what goes with what?
Okay,
I'm so confused.
so we got synthesis, decomposition, combustion, and single replacement, these are all oxidation reduction reaction. Good? And the other class is double replacement. And so if it's not double replacement, then it's oxidation reduction. Does that make sense?
Yeah, I got it now.
Okay? And if it is double replacement, it can either be precipitation reaction or acid-base. We'll talk about these next. So precipitation. So what is precipitation from the meteorologist? Rain, right? Is that what he's talking about? Okay. What has to happen before we have rain? I'm just a little black rain cloud. Clouds, right? I'm sorry.
Can't hit the high note.
Yeah, you're not a singer either.
Ah, my heart is broken. Not even as good as Winnie the Pooh? Come on. Gotta have a raspy voice. Okay. So, anyway, why did I talk about clouds? Because precipitation, when we have two aqueous solutions. You remember what aqueous means? Water solution of salt and water, something dissolved in the water. Two aqueous solutions put together, and I wish I brought this, but I didn't. I'll have to bring it next time. Then it produces a solid. Whoa, you get two aqueous solutions. They look like water. You put them together, and a solid forms out of it. And it just looks like a cloud. I'll show you. Okay? And a precipitate is that solid forming compound. All right, so an example of this is lead 2 nitrate in aqueous solution. That means it's dissolved in water. Plus potassium iodide, also dissolved in water. So your two reactants must be aqueous solutions. Then this is a double replacement reaction. So the cations swap partners. And we get lead 2, because nitrate's 1 minus, right? And if you don't know it, you can do this action. 1 minus times 2 is negative 2, positive 2. There's only 1, so it's 2 plus, right? Do y'all remember this? Okay. So lead 2 hooks up with who? Not K, iodine. The cation has to hook up with the anion, right? So what's the charge of iodine? Look on your periodic table. 1 minus. You with me? Then what do? We cross these charges and we simplify and we get Pb I2. And it turns out that's a solid. That's the solid that it forms. And potassium hooks up with nitrate. Potassium is a 1 plus ion. Nitrate's a 1 minus, so the formula is KNO3. And it turns out that one is aqueous. That one still dissolves in water. There's still water here. But this is how you know it's a precipitation reaction. We have two aqueous solutions, and we're forming a solid. That's it. That's the indicator. We good? Questions? Okay, one last type, and then we'll go deeper next time. Yay, right? Okay. Questions? No? All right, the next one is acid-base reactions. Okay, how do you know it's an acid? H plus as the cation. How do you know it's a base? OH minus as the anion. And we also call these neutralization reactions. And I'll show you why we call it that. We start with an acid and a base, and we will always get a salt. You guys remember salts? An ionic compound and water. We won't always get sodium chloride in water, guys. We will always get a salt, which is any ionic compound, okay? But this is the indicator of an acid-base reaction. So an acid has to have the H plus ion as the cation, and the base has to have the hydroxide anion. So let me go through one example here. So an acid, a strong acid, and in fact, these are strong acids and strong bases. So we got HCl as an aqueous solution. If you don't have this mixed with water, it's not an acid. You have to have a water solution, just like in precipitation reactions. Okay? So all double replacement reactions are aqueous solutions to begin with. Plus, sodium hydroxide is my base, also has to be aqueous for it to be a base. And this is a double replacement reaction. So what salt do I get? Sodium hooks up with chlorine, and it's a 1-to-1 ratio, right? Na plus and Cl minus. And hydrogen hooks up with hydroxide and becomes what? Liquid water. So sodium chloride is still dissolved in water, so we put AQ, and water is the liquid. We good? Can you tell the difference between acid-base and precipitation? Precipitation makes a solid. Acid-base makes liquid water. Yeah.
Could you please do another example of precipitation?
Yes, on your worksheet. Let's look on your worksheet here. So, on section 2, it says classify each of the following as oxidation, reduction, precipitation, or acid-base. And then next time, we'll go a little bit deeper. But we look at the first one, calcium hydroxide and H2SO4. What do those look like? You have the OH. That looks like a base, right? But for it to be an acid-base reaction, you have to have an acid and a base. Is H2SO4 an acid? How do you know it is? Because H is the cation and sulfate is the anion. You with me? So let's write this out. You get calcium hydroxide, aqueous solution, plus H2SO4. And why is there 2 hydrogens, guys? Do you know that? H plus, and sulfate is SO4 2 minus. and we cross those charges down and we get H2SO4. Good? And we get calcium sulfate and H2O. What kind of reaction is this? Acid base. Good? Questions? Yeah.
Oh, so I had one about precipitation. Will we have to memorize the exceptions for the exam?
What are the exceptions?
Like, knowing that lead with iodine is not insoluble, things like that.
Yes, we will, but it's not an exception. That's how you tell it's a precipitation reaction.
Right.
What if
Or
it does?
sorry, the solubility exceptions. That's what I meant to say.
Let's see. I think we deal with that more later. But for now, we're just keeping it a little simple.
Okay.
Yeah. Yeah, because that is an exception. Yeah, you're right. Okay. So the next one, H2O2 breaks down and gives us H2O and oxygen. Does that look like a double replacement reaction? No. So what kind is it? It's a decomposition, but what are we going to call it? Oxidation reduction reaction. Do you get that? Okay, and the next one down, HCl. Ooh, that looks like an acid, right? AgNO3. Ooh, does that look like a base? It doesn't have hydroxide in it. But look at the products. What do we get? Oh, we get a solid forming. So what type of reaction is this? Precipitation. Is it a double replacement reaction? Yes. The silver hooks up with chlorine, and the hydrogen hooks up with nitrate. Good? So that's a precipitation reaction. Do you got the rest of them from here? How to figure these out? Question, Dakota.
Is the like the sixth one on the page? Is it a single replacement or a double replacement?
Neither. Does anybody know what that reaction is? The C4H10O2 plus O2 gives us CO2 and H2O. Gives us carbon dioxide and water.
Combustion.
Ah, that's a combustion reaction. So what type? Is that a double replacement? No. So that means it's oxidation reduction. Do you get that? Anything else?
The double replacement reaction. So hold on. Precipitation reactions and acid-base
Uh-huh.
reactions are in a double replacement
Yes.
reaction, right? Because
Yes.
it changed from, like, one is to solid and the other one is to liquid.
And so, yeah, and so that's an easy way to tell the difference between oxidation or not, right? And if it's not oxidation, it's either acid base or
Acid-base or.
precipitation. And then you look for the solid or the liquid water. Good? Anything else? Okay, that's it. Have a fantastic rest of your night and drive safe.